December 10th, 1941, just 3 days after Pearl Harbor.
By 10 a.m., it's all over. 18 ships, including all...
The Japanese Imperial Army swept across the Philippines, capturing Clark Field from retreating American forces. Among the wreckage, engineers found something strange: a tiny olive drab box on wheels, barely bigger than a farm tractor. They laughed. Compared to Japan's heavy military trucks, it looked like a toy, weak, fragile, and absurdly small. But when they turned the key, everything changed. What started as a joke would become one of the most humiliating engineering lessons of World War II. Because that toy wasn't a toy at all. It was the Bantam Jeep, the machine that would redefine mobility, expose Japan's industrial limits, and quietly reshape the future of warfare itself. December 10th, 1941. The smoke of war still hung heavy over Clark Field in the Philippines. 3 days after Japan's assault on Pearl Harbor, the Imperial Army swept through the ruins of the American air base, scavenging everything of value: weapons, vehicles, and blueprints. But tucked among the wreckage was something so small and unimpressive that it drew laughter instead of curiosity. Parked beside the twisted fuselage of a B-17 sat a strange little box on wheels, its olive drab paint chipped and dusty. Chief Engineer Yamamoto Kenji approached it with a smirk. The machine looked absurd. A short, square contraption with flat fenders and a grille like a child's toy. "Americans build their military vehicles like toys," he muttered, shaking his head. The engineers circled the vehicle, laughing as they measured its tiny 80-inch wheelbase. Japanese military trucks weighed over 2 tons, towering symbols of mechanical strength. This captured Bantam BRC-40 weighed barely half a ton, just 2,132 pounds. To Yamamoto, it was proof of everything Japan believed about American engineering: quick, cheap, and careless. His assistants mocked the flat body panels and thin metal. "A farm tractor could survive longer," one said. Another pointed at its small tires and chuckled, "Even our bicycles are built stronger." Yamamoto's initial report was blunt. This design would not survive the jungles of Southeast Asia. To him, it was just another example of American shortcuts. Yet orders from Tokyo were strict. All captured vehicles must be tested before disposal. So, against their pride, they fueled it up. When the small Continental 4-cylinder engine sputtered to life, the men laughed again. But as the idle steadied into a confident hum, a few faces changed. The clutch moved smoothly, the gears engaged without complaint. Yamamoto climbed into the passenger seat, clipboard ready to document its failure. He didn't know it yet, but the next few minutes would erase everything Japan's military engineers thought they knew about vehicle design, and set the stage for one of the most important industrial revelations of World War II. The engine's hum echoed across the ruined airfield, a mechanical heartbeat in the humid silence of the Philippine morning. Chief Engineer Yamamoto gripped his clipboard, ready to record every rattle, stall, and failure that would confirm his superiority. Behind the wheel sat Engineer Watanabe, whose grin betrayed his disbelief that such a small contraption could even move. "Proceed," Yamamoto ordered. Watanabe pressed the clutch, expecting resistance. But the pedal moved effortlessly. The transmission slid into gear like butter. He touched the accelerator, and the Bantam jolted forward with a responsiveness that no one expected. The laughter faded. Within seconds, the little American vehicle was bouncing confidently across the airstrip. The engineers had tested dozens of captured trucks, heavy, stiff, sluggish machines that required skill to control. But this one felt alive. It turned sharply, reacted instantly, and climbed over rubble as if it weighed nothing at all. "Try the slope," Yamamoto said sharply, unwilling to show surprise. Watanabe nodded and aimed for a muddy incline beside the bombed-out hangars. The earth was thick from recent rain, a surface that had swallowed entire Japanese transport trucks just days earlier. The Bantam didn't hesitate. Its four wheels clawed through the mud with mechanical grace, each tire finding traction as if it knew what to do. In moments, it was over the hill. The engineers stood speechless. No shouting, no celebration, just the stunned quiet of men watching their assumptions collapse. Yamamoto climbed out, his boots sinking in the mud as he studied the tracks behind the Jeep. "Again," he said, his voice thin. Watanabe turned, this time aiming toward rougher terrain. Rocks, ruts, puddles. The kind of path that snapped axles and stranded convoys. The Bantam handled it all. Its short wheelbase allowed impossible turns, and its 48 horsepower engine pushed it forward with stubborn determination. Then came the moment that silenced every doubt. Watanabe deliberately lodged the vehicle between two rocks, pretending to get it stuck. Yamamoto sighed. Finally. But before he could finish writing, two soldiers walked up, gripped the rear bumper, and lifted the vehicle free. Gasps rippled through the group. A military vehicle that could be repositioned by hand. Impossible. For the first time in his career, Yamamoto was out of words. This crude, toy-like American invention had just conquered the very challenges that paralyzed Japan's most advanced trucks. He stared at the little machine as the engine idled calmly, mud dripping from its tires, and realized with a chill that he was witnessing something far more dangerous than a weapon. This was the embodiment of American ingenuity, practical, adaptable, and terrifyingly efficient. That night, Yamamoto sat at his desk and rewrote his entire report. The first line read simply, "The American vehicle works." And with that reluctant admission, Japan's laughter died, replaced by something new, fear. Because what they had discovered at Clark Field wasn't just a machine, it was the first glimpse of how America would fight and win World War II. By sunrise the next morning, Clark Field had transformed from a battlefield into an open-air laboratory. Under a commandeered hangar roof, Japanese engineers gathered around the Bantam Jeep, like surgeons preparing for an autopsy. Their laughter was gone, replaced by a reverent silence as Yamamoto ordered the complete disassembly of the vehicle. Every bolt, every panel, every gear was to be measured, catalogued, and understood. "We will see where their weakness hides," he said, though even he no longer sounded convinced. Engineer Sato began by examining the body panels, his calipers clicking softly as he recorded measurements. 1.6 millimeters, he muttered in disbelief. The steel was shockingly thin, half the thickness of Japan's lightest military vehicles. Yet when he pressed against the panels, they refused to bend. "Sir," he said, "they use geometry for strength." Instead of relying on heavy materials, the Americans had designed the body with bends and folds that created rigidity through form, strength through simplicity. Yamamoto wrote the phrase down but didn't look up. Nearby, engineer Watanabe had dismantled the suspension. His notes were brief. No excess weight. No wasted parts. The leaf springs were short, but perfectly positioned to balance weight over both axles, giving the vehicle remarkable stability despite its size. The transfer case, the mysterious heart of the four-wheel drive system, weighed less than half of Japan's equivalent designs. It used fewer parts, simpler machining, and no unnecessary complexity. "Sir," Watanabe said, holding up the gear housing, "this entire mechanism could be built in half a day." Our version takes 3. Yamamoto walked slowly between the tables, touching the components laid out before him. The engine, a modest 4-cylinder producing only 48 horsepower, had been mounted with surgical precision, every line and cable placed for easy maintenance. The electrical system used just a few standardized connectors that any mechanic could understand. There was no extravagance, no unnecessary innovation. Every decision had a purpose. He stopped at the folded windshield, now removed from the chassis. 2 hinges, 4 bolts, and it collapsed neatly against the hood. Such a small, almost laughable feature carried enormous implications. "You can ship 40% more of these per vessel," murmured engineer Watabe, doing the math aloud. That meant more vehicles, more mobility, more presence on every battlefield. By the time the analysis was complete, the truth was undeniable. The Bantam Jeep wasn't crude. It was brilliant. The Americans had mastered a new kind of engineering, one that valued efficiency over elegance, mass production over craftsmanship. It was the opposite of everything Japan had built its industry upon. Yamamoto wrote his final note of the day. "They build tools. We build monuments." As the team packed up for the night, the chief engineer lingered by the stripped-down frame. In that hollow shell, he saw the shadow of something far larger than a single vehicle. A glimpse into how America would soon overwhelm the war, not with better weapons, but with better factories. By late December 1941, the findings from Clark Field were sent by secure courier to Tokyo. Inside a thick envelope marked "Urgent Engineering Priority" lay dozens of sketches, blueprints, and performance reports. They were stamped top secret and delivered straight to the desks of the Imperial Army's Technical Division and the Ministry of Munitions. When the documents reached Toyota Motor Company's Como plant, Chief Engineer Hanji Umehara studied them in stunned silence. The order from Imperial headquarters was clear. Develop a Japanese equivalent to the captured American reconnaissance vehicle. Maintain identical capabilities. Distinguish design to avoid legal or political complications. To Japan's engineers, it was both a challenge and an insult. Copying the enemy's machine went against their pride. But the data from Yamamoto's field tests left no room for ego. The Americans had built something revolutionary. On December 24th, Umehara gathered his senior team, designer Nakamura, drivetrain specialist Fuji, and a small group of trusted engineers around a single large drafting table. Spread before them were photographs of the Bantam BRC-40, stripped to its bare frame. They studied every angle: the compact chassis, the flat panel bodywork, the transfer case that engaged four-wheel drive with a single lever. "We cannot copy their appearance," Umehara said, "but we must learn why it works." For days, the engineers dissected each system in theory before putting pen to paper. The American engine, a modest 1.8-liter four-cylinder, became the basis for their new design. Toyota's own 2.2-liter Type C engine could produce slightly more horsepower while maintaining the same agility if the total vehicle weight stayed under 2,200 pounds. The body construction was trickier. Japanese vehicles traditionally relied on curved, hand-shaped steel. Elegant, but time-consuming. The Americans had replaced that artistry with geometric precision. Flat panels bent at right angles, bolted together in minutes. It looked crude, but it was the key to building hundreds of thousands of vehicles quickly. By February 1942, the design was complete. The new prototype was christened Toyota AK-10, Japan's answer to the American Jeep. Umehara approved the final drafts with a mixture of pride and unease. On paper, it rivaled the Bantam in power, speed, and maneuverability. But deep down, he knew this project wasn't about engineering anymore. It was about something far larger, whether Japan could match the unstoppable production power that had birthed this tiny, unassuming symbol of World War II efficiency. On March 15, 1942, the prototype rolled out of Toyota's experimental workshop under a pale morning sky. Painted in matte army green, the AK-10 looked like a smaller cousin of the heavy trucks parked beside it. Yet its proportions were unmistakably foreign, compact, angular, stripped of ornamentation. Chief Engineer Hanji Umehara climbed into the driver's seat, while a small crowd of factory workers gathered to watch. He turned the ignition, and the 2.2-liter engine roared to life with surprising vigor. The machine that had started as an American embarrassment was now reborn as Japan's proud experiment in mechanical adaptation. Umehara steered toward a rugged dirt trail behind the Como plant, a path chosen to mirror the brutal testing grounds at Clark Field. The AK-10 tackled each incline and rut with confidence, its four-wheel drive system shifting seamlessly from high to low range. The engineers riding in the back gripped the railings as the vehicle bounded over uneven ground, throwing up clouds of dust. "It handles like the American one whispered. "Better," another replied quietly, unwilling to say it too loudly. The test concluded without a single malfunction. Umehara parked the prototype, stepped out, and saluted the team. "We can build it," he said simply. Within weeks, the AK-10 entered limited production as the Type 4 compact cargo truck. The Imperial Army approved it for reconnaissance and light transport, and the first batch was delivered in April 1942. On the surface, Japan had achieved the impossible, transforming a captured enemy vehicle into a functioning domestic design in just 91 days. Newspapers never mentioned it, of course. The AK-10 remained classified, its existence known only to military insiders. Yet within engineering circles, whispers spread. The Americans had inspired something remarkable, but something far more troubling too. Because while Toyota could now build a vehicle equal to the Jeep, the question looming over every report was one no engineer could ignore. Could Japan ever build enough of them to matter? By mid-1943, those doubts turned into harsh reality. Every month, reports from Imperial General Headquarters arrived at Toyota's Como plant, and each one read like a slow obituary for Japan's industrial dreams. The AK-10 project had proven that Japan could build a machine as capable as the American Jeep. What it couldn't prove was that Japan could build thousands of them. In one corner of his office, Chief Engineer Umehara pinned the newest report beside the last, U.S. Jeep production, 500,000 units delivered. Toyota, AK-10 production, 463 total. The contrast was almost insulting. At Willys Overland's plant in Ohio, American workers, many of them women, assembled 1,500 Jeeps every single day. In Michigan, Ford's Rouge plant produced another 1,000. Japan's entire auto industry couldn't match that output in a month. Even if Umehara doubled his staff, tripled their hours, and worked without sleep, it wouldn't make a dent. The math simply didn't work. America's industrial power had outgrown warfare itself. Then came the material shortages. First steel, then copper, then rubber. By late 1943, assembly lines at Toyota slowed to a crawl. Rows of unfinished AK-10s sat lifeless, missing tires, electrical wiring, or critical gear parts. "We have 59 vehicles awaiting components that no longer exist," one production manager reported grimly. The Army's fuel crisis made things even worse. Even when the trucks were completed, there was often no gasoline to drive them. Some AK-10s were stripped for parts. Others were converted into stationary generators to power field radios. a tragic downgrade for what had once symbolized Japan's leap into modern mobility. Umehara, once proud of the AK-10's engineering perfection, now saw it for what it had become: a museum piece in the middle of a war that no longer cared about precision. America wasn't just winning through technology. They were winning through quantity. And for the first time, Japan's finest engineers began to realize that no amount of skill could overcome a factory system that never slept. By early 1944, the truth was unavoidable. Toyota's engineers had achieved mechanical perfection, but industrial paralysis. Inside the Como plant, assembly bays once alive with activity now stood half-lit and quiet. Piles of unfinished AK-10 frames lined the floor, their metal bodies pristine but useless, waiting for parts that would never come. Copper for wiring was gone. Rubber for tires was gone. Even paint had become a rationed luxury. Production managers stopped reporting daily numbers because they no longer mattered. "We are not manufacturing vehicles," one worker muttered. "We are manufacturing ghosts." Chief Engineer Umehara walked the factory floor in silence, running his hand along the cold metal of an unfinished AK-10. He knew each vehicle by serial number, knew every adjustment his team had made to improve efficiency. They had done everything right: reduced weight, simplified systems, improved reliability. Yet none of it could change the one number that mattered: 497. That was the total number of AK-10s completed before the project was shut down in March 1944. Meanwhile, intelligence reports told a story that defied imagination. America had surpassed 650,000 Jeeps produced, more than one vehicle for every 5 U.S. soldiers deployed across the world. Japanese commanders received reports of Allied convoys where Jeeps were unloaded by the hundreds, rolling onto beaches like ants from a nest. For every AK-10 Japan built, America produced 1,300. When Yamamoto visited the factory that April, he stood beside Umehara and stared at the silent line of unfinished trucks. "We decoded their machines," he said softly, "but not their system." America's advantage had never been about genius or luck. It was about structure. Their factories could run 24 hours without stopping. Their workers could produce 10 times more steel, 5 times more rubber, and 100 times more vehicles than Japan ever could. The AK-10 would remain a symbol of what Japan could create, but also of what it could never sustain. In the end, technical brilliance had met its greatest enemy: industrial reality. April 1944. The war had turned decisively against Japan, and inside Toyota's Como plant, the last echoes of production faded like a dying heartbeat. Machines stood silent under layers of dust, conveyor belts motionless, lights dimmed to conserve power. The once proud factory that had given birth to the AK-10 now felt like a mausoleum, a monument to effort crushed by arithmetic. Every success story in its blueprints had been erased by the sheer scale of America's industry. Across the Pacific, Willys and Ford were producing more Jeeps in one day than Toyota had in the entire war. Photographs from U.S. shipyards showed rows of the little vehicles being hoisted aboard transport vessels by cranes, hundreds at a time, destined for Africa, Italy, and the Pacific. Each was identical, each reliable, each built by a system that treated mass production like a weapon. Meanwhile, Japan's engineers were salvaging scrap metal just to finish a handful of vehicles that could never leave the mainland. Chief Engineer Umehara still came to work every morning. He reviewed reports that no longer mattered and signed documents for materials that would never arrive. "We matched their design," he told one subordinate, "but not their scale." Even in defeat, the AK-10 had proven that Japanese craftsmanship could equal American innovation. But craftsmanship was slow, deliberate, personal. The war now demanded speed, repetition, and numbers. By May, orders arrived from Tokyo to halt production indefinitely. Umehara read them twice, then looked across the empty floor where the last AK-10 sat, the 497th unit. Its paint was still fresh, its engine untested. He placed his hand on its hood and whispered, "You were perfect." But perfection didn't win wars anymore, not in World War II. The era of craftsmanship had ended. The era of production had decided the future, and Japan, for all its brilliance, had simply run out of time. When the war finally ended in August 1945, the echoes of industry told the real story of defeat. Japan's factories lay in ruins, its ports silent, its railways twisted like wire. Yet in the wreckage of the Como plant, one machine still stood beneath a tarpaulin, an AK-10, engine preserved, frame untouched. Chief Engineer Hanji Umehara returned weeks later to inspect what had once been his life's greatest achievement. Dust covered the once glossy olive paint. The factory smelled of rust and oil. To anyone else, it was just another relic of a lost war. But to Umehara, it was something more. The embodiment of a painful truth. Japan hadn't lost because of inferior minds, but because of smaller numbers. In total, only 497 AK-10s had ever been built. By contrast, America had produced over 650,000 Jeeps by the end of World War II. For every vehicle Japan managed to assemble, America created over 1,000. The Bantam, once laughed at by Japanese engineers, had become the beating heart of Allied mobility, ferrying troops across deserts, mountains, and jungles, while Japan rationed tires and gasoline. When Admiral Yamamoto had warned years earlier, "I fear all we have done is awaken a sleeping giant," he hadn't just meant America's soldiers. He meant its factories, its workers, its machines. That sleeping giant had awakened and conquered not through brilliance, but through output. Every factory worker in Detroit, every welder in Pennsylvania, every woman on the assembly line had been part of a greater army. One Japan had never prepared to fight. Umehara's final report to the Ministry of Munitions contained just one haunting line. "We successfully copied their engineering. We could not copy their factories." Decades later, when Japan rose again as an industrial power, Toyota engineers would still whisper the story of the AK-10. It wasn't a story of failure. It was a lesson carved in steel. That in the modern age, wars aren't won by the best machines, but by the nations that can build them faster than they can be destroyed.